Welcome to this video on rearing mealworms. In this video, we discuss a technique to successfully rear mealworms. The practical actions are also shown to you so that you can get started as a mealworm breeder. We'll start with an introduction of the mealworm itself. What are the applications and what does life cycle look like? And then I'll explain the rearing process for each stage of the insect's life. And we end this video with potential problems you may encounter while rearing. If you want to start rearing mealworms, you must of course know what you're dealing with. Therefore, first a brief explanation about the mealworm itself. Mealworms are actually the larvae of the mealworm beetle. The beetles are shown on this video. It's a black beetle which is about 2 centimeters in size. This stage is the adult insect and only they are fertile, so they ensure reproduction. So mealworms are the larvae of the mealworm beetle and they are of most interest for certain applications. Depending on their diet, the larvae contain about 55% proteins and around 30% fat. This allows them to be used in human food, but they are also popular as pet feed or feed for aquaculture. And they can also be used for technical applications such as bio-based chemistry. Mealworms go through several stages before transforming into the adult mealworm beetle. They undergo a complete metamorphosis. This means that they undergo a pupae phase before they reach the adult stage. Depending on environmental factors such as climate and diet, the complete life cycle lasts between 3 and 4 months. After about 4 days in the adult stage, the beetle will start laying eggs. And these eggs hatch after about 8 days. The mealworms are then still very small and transparent. We then speak of glassworms. After 8 to 10 weeks, the mealworm is fully grown and will pupate. The pupae transform into adult beetles after 1 to 2 weeks. The mealworm beetle will have a white color for the first few hours, and then it becomes brown, and when the exoskeleton is fully cured, they will have a black color. And then the life cycle is complete. To start with a mealworm colony, you will have to go through a few steps. We will now discuss these steps. First, you'll need to choose the rearing form. This means, will you only produce mealworms or will you also reproduce and thus keep all life stages on the insect rearing facility? If you have made your choice, you will of course have to procure certain materials and provide good accommodation for the insects. And then you can really start rearing. We now discuss each step more in detail. The first step is to choose a rearing form. Do you prefer to produce mealworms or also reproduce them? If you choose for production only, one life stage occurs on a rearing facility, namely the mealworms or a larva phase. The insect breeder keeps the mealworms until they are fully grown and then they are harvested and sold. The start population is purchased elsewhere in the form of eggs or larvae of several weeks old. This rearing form can be of interest to people who do not have time for insect reproduction or those who rear seasonally. In some cases, it may be more profitable to only produce, but this is very company specific. In some cases, it also can be more profitable to reproduce the insects and to keep all insect life stages on the rearing facility. In that case, the breeder provides itself with a new supply of new mealworms to sell, and you will then keep a number of rearing crates containing the larvae from the production phase aside so that they can pupate, and then the beetles can be used to lay eggs and thus provide new mealworms. Here we see an example of a very small-scale mealworm facility. The rearing crates are stacked at insect life stages so that the overview remains clear. For example, here we have the oviposition crates where the beetle lay eggs, and twice a week they are transferred to the larvae stack where they can grow into full-grown mealworms. When pupae are located in the larvae crates, new pupae crates are started up and placed in this pile. And when the pupae develop into beetles, they are collected in the beetle rearing crates, and then beetles are selected to lay eggs again. So in this example, reproduction takes place. It is recommended to separate reproduction and production from each other in different rooms to limit any potential spread of diseases. So the larvae used for sale are then located in a different room, and the larvae intended for pupation are kept in the reproduction room. If you have chosen your rearing forum, you can then provide the required equipment and then you can start rearing. We first discuss the required infrastructure to rear mealworms. The rearing facility best consists of 3 different rooms, one for production, one for reproduction, and one workspace to perform actions such as harvesting or feeding. If you want to only produce mealworms, you'll only need 2 different rooms. The rearing chamber must be equipped to ensure that the insects can be grown at an optimal temperature and humidity, so preferably choose a room with the option of climate control. The rearing chamber must therefore be well insulated to ensure a stable climate. An optimal humidity for the rearing of mealworms is 60 to 70%. Especially during reproduction, a humidity that's too low can cause problems. The eggs can dry out below a humidity of 50%, which causes lowered yields. Moreover, the reproduction capacity of the beetles itself will also decrease if the humidity is too low. And a too high humidity will stimulate the growth of unwanted organisms such as mites. An optimal temperature to rear mealworms is between 25 and 27 degrees Celsius. If the temperature is too high, overheating will cause death, as the temperature in the rearing crates is higher than the ambient temperature because the mealworms produce metabolic heat. At a temperature that's too low, the development will decrease and the mealworms will not obtain optimum final weights. All life stages prefer dark conditions. It is therefore best to choose a rearing chamber with as little natural daylight as possible. If this is not an option, you can also place lids on the rearing boxes. Furthermore, the provision of a ventilation system is also required as rearing mealworms creates dust, but it must also be possible to remove gases such as ammonia and carbon dioxide. Moreover, a ventilation system also brings oxygen into the rearing chamber. In order to give an idea of the required infrastructure, we'll take a virtual tour in a mealworm rearing facility as an example. We now enter the mealworm production room where the climate is controlled. And next we enter a separate workspace, the harvesting room, where the fully grown mealworms are harvested and thus separated from their substrate. The mealworms are harvested using a vibrating screen as shown here on video. Of course, you will also have to purchase some equipment if you want to start rearing mealworms. We distinguish material for production and for reproduction. For mealworm production, you'll of course need rearing crates. Stackable rearing crates of 60 by 40 centimeters are commonly used for this, but different dimensions can be used if you apply the correct density. In any case, make sure that there are enough openings to provide the insects with fresh air, as the rearing crates will be stacked. The mealworms are harvested with a sieve with a mesh size of 2 mm. This can be done manually for small productions, but for larger productions a vibrating screen is recommended as shown here. It is best to provide transport carts or something like that for moving the rearing crates. And to weigh the feed for the mealworms or to weigh the harvested mealworms, it is best to have a scale at hand. Furthermore, equipment for chopping the feed and cleaning the rearing crates is also recommended. Of course, you'll also need to buy a started population. You'll need the same equipment for reproduction, as production then also takes place on the rearing facility, but you'll also need additional equipment. It is recommended to buy a fish grater of 3.5 millimeters. This is used to separate pupae from the mealworms. An oviposition mesh is also recommended for the beetles because they behave cannibalistic towards their eggs. And a separating machine which separates dead beetles from the living ones can also be made. This is based on the principle that the living beetles can attach themselves to the mesh of the conveyor belt while the dead beetles fall down. Another required material is of course the insect feed. Mealworms are provided with dry feed and a wet feed as a source of moisture. Wheat bran is used as a standard dry feed and carrots can be used as a moisture source, but other vegetables such as chicory roots or even fruit can also be used. The wet feed is best chopped to make it easier to process for the insects. If the mealworms can't fully process the wet feed, this can cause unwanted fungal growth in the rearing crates. The beetles have the same eating habits as the mealworms and can therefore be fed with the same feed. If you have made your choice whether you will produce or also reproduce the insects, and you are provided with the equipment to do so, you can start rearing mealworms. We'll now go through the different steps of the rearing process. If you only produce mealworms, the rearing process consists of rearing the mealworms and harvesting them. When the reproduction of mealworms is also carried out, the rearing process consists not only of rearing and harvesting mealworms, but also of further growing into beetles, which are then used to lay eggs. We'll start with the production of eggs or young larvae to fully grown mealworms. If you also want to reproduce the insects on your facility, it is best to already define which rearing crates will be used for further rearing into beetles and which rearing crates will be used for production only. Mealworms used for reproduction are placed in the rearing crates with a lower density, so they have more space to grow and therefore have a higher quality for reproduction. For mealworm production, a density of 20,000 mealworms per crate of 60 by 40 centimeters is used, and for reproduction, a density of 5,000 mealworms per crate is applied. Per kilogram of produced mealworms, you'll need 2.1 kilograms of wheat bran in total. So if you use a rearing crate with a density of 20,000 mealworms, you'll need 4.2 kilograms of wheat bran. You can give the dry feed to the mealworms all at once, but make sure it fits in your rearing crate. Otherwise, you'd have to give the dry feed in 2 or 3 times. It is highly important that you respond to the insect's needs. Basically, you have to feed them ad libitum. So when all feed is processed, provide them with more feed, otherwise your yields will decrease. Fully processed dry feed looks like a powder presented here on the picture. If you see this powder and almost no bran is present, immediately feed the mealworms. Larvae till 2 weeks old don't need to be fed with a moisture source as long as the relative humidity is optimal. Moreover, they are not able to process the wet feed until then. When they are 3 weeks old, provide them with the wet feed at least 3 times a week. Also here, it is very important that you respond to the insect's needs. If by the next time you feed the insects, the wet feed is fully processed, provide the mealworms with some more wet feed. And if not, provide a little less to prevent problems with fungi. Young mealworms don't need much wet feed as they are very small. The first weeks they only need approximately 50 grams per feeding. And as they grow, you need to provide them with more. In the last weeks, they'll need a couple of 100 grams of wet feed per feeding, of course depending on what type of wet feed you use. We are now looking at a video that shows the actions of feeding the mealworms. Here we see the preparation of the wet feed, in this case carrots. They are shredded, which makes it easier for the mealworms to process the wet feed. The wet feed is then taken to the rearing chamber. The stack of rearing crates to be fed, in this case the larva stage, is taken. If necessary, the dry feed, in this case the wheat bran, is added first and spread throughout the rearing crate. We take a look at the rearing crate itself. The carrots are spread over the entire rearing crate. And when the mealworms of the last rearing crate of the stack are fed, the stack is put back in place. Once the mealworms are fully grown, they can be harvested. This will be after approximately 8 to 10 weeks. Here the growth curve of the mealworms is presented. First, the mealworms will gain weight and it stagnates. When the mealworms transform into pupae and beetles, their weight will drop. When the mealworms no longer gain weight, they are harvested. You can recognize this on the activity of the larvae. They move less quickly when they are fully grown. It is possible that there is a small variation on the age of the mealworms and that there are already some pupae present in the rearing crate. You can also see this as an indication that the mealworms can be harvested. Maximum 2 days before the harvest, it's better to not supply them with feed anymore, because then they will process all the feed left in the rearing crate so that you can easily separate the residual substrate from the insects using a sieve. In the rearing crate of 60 by 40 centimeters, you can produce 2 kilograms of mealworms if all conditions are kept optimal. You can harvest mealworms manually or mechanically. The manual harvest is done with a sieve with a mesh width of 2 millimeters. The residual substrate falls through the sieve while the mealworms remain on top of the sieve. Manual harvest is only possible for small productions because it is very labor intensive. To harvest large volumes of mealworms, it is recommended to use a vibrating screen as shown here in the video. The vibrations will separate mealworms from the residual substrate. The mealworms are then collected. Here also a sieve with a mesh width of 2 millimeters is used. The mealworms can then be sold alive or slaughtered by, for example, freezing them at -20 degrees Celsius. If you also want to reproduce mealworms, you will have to keep some of the mealworms from the production department aside to let them transform into pupae. Mealworms are cannibalistic, and mainly the immobile stages such as the pupae suffer from this. It is therefore important that you separate the pupae from the larvae from the moment there are pupae present in the rearing crates. This is done with a 3.5 mm mesh fish grater as shown here on the picture. You separate the pupae from the larvae with a frequency of 1 to 3 times a week. The more often you separate them, the better the cannibalism remains under control and the smaller the spread on the age and thus the transformation of the pupae to beetles later. Every time you separate the pupae, you start a new rearing crate for those pupae. You can mix pupae from different larvae rearing crates. The pupae do not age, but you can provide a little dry feed for when they transform into beetles. It takes up to 4 weeks, depending on the spread, for all mealworms to pupate. Here we see how the pupae are sieved using a fish grater. The mealworms are thinner and more mobile than the pupae, so they will fall through the sieve together with the substrate. The pupae will remain on the sieve and can then be transferred to a new pupae rearing crate. Because you have started a new pupae crate every time you separated the pupae, they will be about the same age and transform into beetles almost simultaneously. The beetles are also cannibalistic, but with a small spread on the pupae's age, cannibalism is minimal, so you don't have to separate the beetles from the pupae. When the pupae are transformed into beetles, you can easily move the pupae rearing crate to the stack of the beetle crates. Make sure that they have enough feed because, unlike the pupae, the beetles do eat. If you have sieved pupae only once a week, the spread on age is larger. You can then use an egg carton that you put in the pupae rearing crate. The beetles that are present in the pupae crate will crawl on it. With the help of the egg carton, you can then easily transfer them to a beetle rearing crate, but I will clarify this with a video. In this video, we see that some pupae are transformed to beetles, so they are present in the rearing crates with pupae. The beetles crawl on the egg carton and can therefore easily be transferred to the rearing crates in which the beetles are collected. Beetles from the beetle rearing crates will be selected to be used for reproduction and thus to lay eggs. If you provide the beetle rearing crates with an egg carton, you can also use this to collect the beetles for reproduction. The beetles that are able to crawl and stay on the egg carton are fit and therefore suitable for reproduction. After collecting the fit beetles, they will be placed in an oviposition crate. It is highly recommended to use an oviposition mesh in the crates because the beetles behave cannibalistic towards their eggs and can therefore damage them. The beetles will use their ovipositor to lay eggs deep into the oviposition substrate through the holes of the mesh. The mesh will separate the beetles from the laid eggs with a higher yield as a result. For the oviposition mesh, a mesh size of 2 mm is used. Twice a week, you replace the oviposition crate with a new one. The old crate containing the eggs will be transferred to the pile with the larva crates. You can use the beetles for reproduction for 4 weeks, and after that the reproduction decreases and you'll have to replace them with younger beetles. But I'll illustrate everything using some videos. In this video, we see how the beetles that were collected in the beetle rearing crates are selected for the oviposition crates using an egg carton. The beetles that are able to stay on the egg carton are still fit and therefore suitable for reproduction. You shake off the beetles in a container and then you can use them to start up an oviposition crate to produce eggs. Now, how do you set up such an oviposition crate? We take a look at this. So first you take a clean rearing crate and you provide it with some substrate. Wheat bran is used as oviposition substrate so when the eggs hatch, the larvae can immediately start eating. You do not have to sieve the hatched larvae later, but you can move the rearing crate to the larval pile with the oviposition substrate still in it. An oviposition mesh is then placed in the rearing crate and a little wheat bran is provided on the mesh as feed for the beetles. Wet feed is also placed on the mesh. You do not have to chop these carrots because otherwise they will fall through the mesh more easily and this will contaminate the oviposition substrate. The previously collected beetles are then added to the rearing crate. For a rearing crate of 60 by 40 centimeters, you use about 200 grams of beetles. And this is how the rearing crate to produce eggs finally looks like. If you don't have to start an oviposition crate with new beetles, but you do need to replace an existing crate containing eggs because they are about to hatch, proceed as follows. So you take the old oviposition crate and you place it next to a new one. You provide the crate with the oviposition substrate wheat bran. You can then simply transfer the oviposition mesh with beetles to the new crate. You place the old oviposition crate, which now only contains eggs and wheat bran, on the larva stick. You do this twice a week until the beetles are 4 weeks old, and then you start an oviposition crate using new, young beetles as shown in the previous video. If you prefer to harvest pure eggs, start an oviposition crate with wheat flour as oviposition substrate. The eggs can be sieved from the wheat flour with a 500 micrometer sieve. In this video, the eggs are sieved using vibration. And this is what the beetle's eggs look like after they are sieved from the wheat flour. And here I show you an example schedule for 1 week of rearing mealworms. You feed the mealworms on, for example, Monday, Wednesday and Friday. This mainly concerns the moisture source if the mealworms are already 3 weeks old, or the dry feed if necessary. If pupae are present in the larvae crates, sieve them with a frequency of 1 to 3 times a week. You can do this, for example, also on Monday and or Wednesday and Friday. The pupae do not eat, so it's sufficient to check the feed only once a week. Every month you start up a new oviposition crate with new beetles from the beetle rearing crates in which they were collected. On Monday and Friday, for example, you start up new oviposition crates, but you can use the same beetles if they are less than 4 weeks old. You also feed the beetles with a frequency of 3 times a week according to their needs. While rearing mealworms, you may encounter some problems. We will discuss this topic now. For example, the insect breeder may suffer from allergies because rearing mealworms involves a lot of dust. The mealworms themselves can also contract diseases, or vermin can creep into the rearing facility. Especially during sieving and feeding the insects, a lot of dust is produced from the dry feed, the insect skins and so on. This is detrimental to the health of the insect breeder, but it can also trigger some allergies. So it is important that you protect yourself while performing these actions. Wear protective clothing like the colleagues here on the picture, and preferably wear a mask with an FFP3 filter. Also make sure that you regularly vacuum the rearing facility and clean it with water. It is also recommended to provide a local extraction for the dust. Insect pathogens are generally specific to invertebrates and therefore not harmful to humans. We distinguish 3 types of diseases that can occur when rearing mealworms, namely fungi, bacteria and nematodes. Nematodes often work together with bacteria that make the mealworms sick. You can notice a bacterial infection by dark spots occurring on the affected mealworms. At an evolved stage, they die and they will turn completely black. Diseases are often accompanied by high humidity. You can prevent the spread by lowering the humidity, for example, to 50%. It is best to remove affected mealworms from the colony. A number of pests could also occur in the rearing facility. Pests will compete with the mealworms for food and space. In addition, they can damage the eggs. Common pests are meal moths, larder beetles, and mites. Meal moths are small and mainly active at night, so they are often not noticed until it's too late. The larvae of these moths live in the rearing crates and can damage the colony. You can recognize them by spins they make in which the larvae pupates. The larder beetle eats all kinds of vegetable and animal products, so they too can bring a lot of damage to the mealworm colony. The larder beetle is smaller than mealworm beetles and the larvae are hairy. For both pest insects, you can use sticky threads and insect traplines to reduce their reproduction. The best method is to remove contaminated rearing crates, but this is not always possible. Then, mites can also be a pest. They are very small and therefore not always noticed. The picture on the right shows how you can recognize them. They develop mainly at high humidity, 70% or higher. To slow down the development, you can temporarily lower the humidity to 50%. Anyway, try to check the rearing crates as much as possible, or even schedule this so immediate action can be taken when pests are present in the insect rearing facility. Now I will give some tips to prevent and monitor problems on the rearing facility. First of all, ensure a good industrial hygiene. Clean and sterilize the material you're working with if there is any disease present on the rearing facility. Avoid stress of the insects. If they feel good, they will be more resistant to diseases. Provide genetic variation within your population. A higher diversity makes them more resistant to diseases. First, put your new population in quarantine so that you can certainly not bring diseases into the rearing facility. Check the behavior and appearance of the insects as much as possible, and if you see abnormalities, it is best to remove the affected insects. And with that being said, we have come to the end of this video. I hope I have informed you well on the rearing of mealworms, but if you do have some questions, you can always send a mail to the email address present on the PowerPoint. Thank you for watching.